Alright, hello everyone and welcome to another episode of Power Logic. So today we're gonna go to problem 6. Consider the L-shaped region formed by 3 unit squares joined at their sides, as shown below. 2 points A and B are chosen independently and uniformly at random from inside the region. The probability that the midpoint of AB also lies inside this L-shaped region can be expressed as m over n, where m and n are relatively prime positive integers. Find m plus n. Okay. So let's think about that first. What is the possibility that we can make their midpoint to be outside of this L shape? Which, well, it's not gonna lie within this region, but only within this part. Well, because you don't have a point that is outside of this L shape. That's not allowed. So essentially, you can only have one point that's over here and another point here, and then you connect. The midpoint is gonna lie somewhere outside in this kind of missing square. So that's the possibility. Okay, so now we have to consider what kind of distribution would cause 2 points to be like that. Now let's consider this square right over here. So let's think about that. If we have one point that is, well, let's say somewhere here inside this region, then is there a way that we can place another point in this L-shaped region such that their midpoint is gonna lie inside the missing square? Well, let me just draw this missing square over here to probably be more clear. Probably not. Well, because if we have midpoint somewhere, like let's just say inside here, then the other point must be somewhere here, which is obviously not gonna be in the L region. So therefore, from here we know that we cannot have a point that lie within this blue region. Okay, so what does that mean? What if we have 2 points in this region? Oh, if we have, well, let's just mark this region to be S1 and this region to be S2. Then essentially, if we have 2 points within the S1 region, then their midpoint must be in S1 and same as S2 because they're basically symmetrical. So what does that tell us is that we must have one point in S1 and 1 point in S2 for midpoint to, or that's not a vector, to be in the Okay, so, but are we done? Well, are all the possible distribution of the 2 points gonna make a midpoint in this red square? Well, what if we have something like this? 1 point on the left and 1 point here. Then if we connect these, that does not look like in the red square, does it? So basically we have to find the specific distribution or the specific region that both points are strictly lied in so that its midpoint is gonna be in the red square. But how are we gonna solve that? To do that, we're gonna use coordinate geometry. So let's just define a point in S1 with coordinate x1, y1, and remember we have to make x1, y1 satisfy some kind of restriction. So essentially, the x value must be between 0 and 1. But the y value must be between 1 and 2, because clearly this is 1 and we have a unit square above a unit square. Then the y altitude must be 2. So essentially, we have these following inequality that 0 is less than or equal to x1 is less than or equal to 1, and 1 is less than or equal to y1 is less than or equal to 2. Okay, now what about S2? Same, we're gonna define a point and call it x2, y2 instead. And we also have, now because it's basically symmetrical, then we basically just swap x2 and y2 with x1, y1. We're gonna get that now instead of y2, we're gonna have 1 is less than or equal to x2 is less than or equal to 2, and 0 is less than or equal to y2 is less than or equal to 1. This kind of restriction. Now, if we connect these 2 points, then let us call this to be the midpoint. Now remember the midpoint formula, then that is actually x1 plus y1, or x1 plus x2 over 2, and y1 plus y2 over 2, because you're basically taking the average between the y coordinate and the x coordinate of the endpoint respectively. So now, what are the coordinates of the 4 endpoints of this red square? Well, here we have a 1, 1, and here we have a 1, 2, and here we have 2, 2, and here we have 2, 1. So this basically means that any point within this red square is going to satisfy the system that 1 is less than or equal to x1 is less than or equal to 2, and 1 is less than or equal to y1 is less than or equal to 2. But yeah, so we can just say that their midpoint is going to be greater than 1 for both. So therefore, we're going to obtain a system of equation that x1 plus x2 over 2, that is greater than 1 and technically greater than equal to 1, and then y1 plus y2 over 2 is equal to 1 as well. Now this basically just simplifies to x1 plus x2 is greater than equal to 2, and y1 plus y2 is greater than equal to 2. So now, these are basically equations of 2 lines, so this actually makes us think of coordinate geometry, specifically geometric probability. Basically, we find the probability by doing a successive region over the total region. So we're going to compute this value instead of number of cases. Now let's think about that. Remind us of the restrictions. Well, what does 0 is less than or equal to x1 is less than or equal to 1 mean, and 1 is less than or equal to, 1 is less than or equal to x2 is less than or equal to 2 mean? Well, let's just label the axis to be, for this to be x1 and for this to be x2. Then any point is going to be a function or an output of on this graph as an input of x1. So if you're more used to the xy coordinate plane, then just treat x2 as y, and that's basically the same thing. Now x1 must be between 0 and 1, So let's just label our axis really quick. 1, 1, 2. So 0 and 1. So essentially these are all the x1 values, and these are all the x2 values. So essentially we have to enclose this region. And it turns out to be perfectly a square, well, even though this drawing does not seem to be a square, but just to let you know that it's not like really drawn to scale. So here we have this length to be 1 and this length to be 1. So now let's draw the line of x1 plus x2 is greater than or equal to 2. So x1 plus x2 equal to 2, while x2 is greater than or equal to negative x1 plus 2. So essentially we're going to have a line with an y-intercept of 2 and a slope of negative 1. Okay, so now greater than or equal to basically just means this region. And let's do color in this region. Okay, so well, what is the area of this region? Well, this is basically just 1/2 of the total area. Because this is 1 and this is 1, and A is just equal to 1/2 times BH, just 1/2. And the total area is going to be 1 squared. 1, so P is going to be 1/2. So this basically just means that, so P just means, so P over here is basically means that P of x1 plus x2 greater than 2, such that 0 is equal to x1 is less equal to 1, 1 is less equal to x2 is less equal to 2. So that is 1/2. And what about y? Well, y is exactly the same, so P of x is actually equal to P of y. And now, are we done? Well, is it just 1/2 square? Well, no, because we know that this distribution is actually uniform. So essentially, we have to also consider the case of what is the probability that we're going to choose 2 points within this L-shaped region, such that one of the point lies in S1, one of the point lies in S2. Well, we have 2 ways to order S1, S2 because the order does not really matter. Well, actually, the order does matter. So we can have S2 and S1, so we choose S1 first and then S2, and we can also choose S2 first and then S1. So essentially, we're going to have 2 ways and out of 9, which 9 is basically, well, if you just write it more clearly, it's going to be 1/3 times 1/3, because 1/3 probability to choose any of the 2, and then we multiply by 2 factorial because there are 2 ways to order them. Now we multiply again by 1/2 square. But what does this probability represent? It represents the probability that it's gonna lie within the red region, but we do not want it to lie within the red region. We want it to lie in the L-shaped region. So essentially, we're gonna subtract this by a 1. Subtract this from 1 to get that. Oh, this one is actually 1 minus 1/9 times 2 times 1/4. which is equal to 1 minus 1 over 18, giving us 17 over 18. So essentially the answer is 17 plus 18 is equal to 35 as our final answer. Thank you for watching. I hope you enjoyed, and I will see you in the next video. Goodbye.